Hello, this was the example I wrote on the board right before the quiz, and I said I would write up a little video giving a little explanation in case you get stuck trying it on your own. So remember, we're trying to determine whether these two lines in space are equal or parallel but not equal, or they're intersecting, or whether they're skew. So in order to do that, we got our two lines. Probably want to think of this as our two vector forms of these parametric equations. So for L1, if you look at the constant terms, that's going to be giving us that R1 of S, because your parameter is S, would be equal to the starting point vector of -1, -1, -4, plus t times, now looking at the variable terms, coefficients. Oh, and that is not a parenthesis, that's a vector. 2, 1, 1. All right, so there's our two lines, or excuse me, there's one of our lines. The other one, very similar, L2. Now that would be R2 of t would be equal to -3, 8, 5 plus t times 1, 3, -2. And remember, each of those, I wrote it in parentheses because the pair or triples would be x, y, z. So those components match up with the x, y, z. All right, so let's take a look. If you look at their direction vectors, v1 and v2, if you look at those two direction vectors, they are not equal. So v1 does not equal v2. So that tells us not parallel, and definitely not the same line. So not parallel, not equal. So we're looking at whether they are intersecting or skew. So that's our question. Intersecting. Do they intersect, or are they skew lines? All right, well, we just need to find out if they have an intersection point. How do we know if two lines intersect? Well, if I look back up here, that means that the x and y and z would need to have some common point between those. So we're actually setting up a system of equations. We would be looking at a system of equations where the x's are equal to each other. So 2s minus 1 equals t minus 3. The second system, or excuse me, the second equation in our system would be s minus 1 equals 3t plus 8. And the last one, s minus 4 equal to -2t plus 5. All right, and not the easiest form to see. It'd be kind of nice if the s's and t's were on the one side together and then the constant terms on the other side. So I'm not going to eliminate or anything quite yet. I'm just going to kind of rearrange. So I'm going to take the t over to that side and then get the -1 over to the other side. So that's going to be 2s minus t equals -3, it'd be plus 1, so -2. Then s minus 3t equals 9. And then s plus 2t equals 9 also. All right. So the one that would, you remember how to solve a system of equations by either substitution or elimination. I'm seeing that these two can eliminate pretty easily by multiplying a negative by that second one. So that way it's s minus s. So you just got to watch your sign when you distribute through to those. So s minus s would be eliminated. Then negative 3t, now distribute the negative, minus 2t, that would be negative 5t. And then 9 minus 9 equals 0. So t equals 0. All right, so we found a t that could possibly be a solution. T equals 0. And then we would want to try to find an s. Trying to think, which one should we find the s in? Probably about the same either way. If I go, we'll just pick one of them, s minus 3 times 0 equals 9. So then that would be 0, so that would be s equals 9. All right. And then, so that essentially solves that 0, 9 is a solution for those two equations in the system. We need to see if that's also a solution to that third equation. Remember, it would need to be true for all three coordinates, right? You could have an x and a y that are the same, but then there's z. It's on a different level. So in 3 space, they may not connect or intersect. So let's see if we plug those in. Let's see if that's a true solution to that first equation. So 2 times, I wrote an ordered pair. I suppose that's not really ordered per se, so we should, not like any standard way. So t was equal to 0 and s was equal to 9. So I'm just making sure I get that plugged in right. So right, we have 2s minus t equals negative 2. That's our first equation that we're going to check. Plug in 9 in place of the s. So 2 times 9 minus 0 equals negative 2. 2 times 9 is 18 minus 0 equals negative 2. And we would see that that's actually false. False, right? So that system of 3 equations does not actually have a solution for s and t that make it true for all 3. Therefore, there is no intersection point. If there was an intersection point, it would happen at the ST combination that then you could plug in and calculate your x, y, and z, and it would be the same for both lines. But no intersection. Therefore, answer, skew lines. All right, hope that helps.